Okay, so we are back to this issue about which device or which element is actually going to be responsible for communicating this change of IP address. Therefore, we have two choices. One is to allow the host to do it, okay, and what in mobile IP they have done in managing the solution for IP before is they have created two new components, okay. This is going back to the issue of the security guard. So basically what happens is they create a new concept called home agent in this point, and they create another concept called a foreign agent. Now with the help of these two elements is how the mobile IP is actually managed. Now what happens is basically the corresponding node will communicate with the home agent. Now, when the mobile node actually moves from point A to point B, what will happen is the mobile node A will register with router B. Router B will become a foreign agent by actually communicating with the home agent. So, what will happen is basically now mobile node A will inform home agent that I am in router B and this is my foreign agent, and therefore in the routing table we have a binding table. Basically what will happen is that the home agent will maintain this information. So when the corresponding node sends the information to the home agent will redirect that message to actually the foreign agent, which is coming back to foreign agent, and which will actually send the message to mobile node A. Therefore, this protects the corresponding node from actually getting involved with a complicated situation of actually being constantly updated. That means every time mobile node A moves, it informs corresponding node on its own. And that process, as I told you earlier, the speed or velocity of movement of the mobile node is of fundamental importance. And you can imagine if every time this mobile node moves and it had to inform the corresponding node, it will take a lot of signaling and a lot of issues that needs to be done. So what will happen is basically this is a beautiful diagram done by Cisco, and they have actually illustrated this issue about mobile IP management in a very beautiful and good manner. So you can look at host B. I'm just going to reiterate what I've actually mentioned to you about mobile IP. So host B is communicating with mobile router with the IP address respectfully, and what happens is mobile router moves exactly as what I've explained. So mobile router A moves, and the IP addresses, as you can see, will eventually, this is the original IP address, and it's moved to gateway C. Now what happens is when it wants to communicate using the original address, gateway A replies to host B with an IMCP unreachable message telling you because of the movement and it no longer is in that place. Then what happens is when even mobile node A wants to send a message, because gateway C has not registered itself as its foreign agent, therefore that also is not possible to be done. So the issue is now, where is mobile router 171.68.690 is moved. So in another simplistic manner, we just call it mobile node A. So when it moves, basically, now the issue is, okay, how do we know that it's moved? When it moves, its IP address will change, and as I mentioned to you, informing the change of IP address is an issue because of the number of signals and the number of repetitions this process would need to be actually repeated in every form. Therefore, when you look at this, what was the solution provided in this form? Basically, mobile IP before, as I told you, we have a foreign agent present in the solution, and in the foreign agent you will use the concept of going back to, if you remember I had written earlier, the care of address to that, and this is the care of address of basically the foreign agent will become the care of address and the COA, and care of address meaning that it's going to be the middle person going to care of address, take care of the messages which are coming in. So you have a mobility binding table which is maintained by the home agent, and you can see the mobile router which originated from 171.68690, which is the original identification which we want to so very much keep as an identifier that does not change, and it has a care of address which is 140.31.2.1, which forms the binding address between them. So when host B sends a message to the home agent forwards the packet to the mobile router via the care of address using 140.31.2.1 address. So that, and then they send the message, and upon sending the message, you will have another the next slide after this will explain to you clearly how you form the triangle routing that actually is formed. Now we're looking at this concept so you can understand that the mobile IP v4 solution for mobile IP management involves the mobile node itself, involves a new concept called home agent, which is actually defines the mobile IP enabled gateway acts as a location database of the mobile nodes, and then you have the concept of foreign agent, which uses the addresses of the care of address. Now looking at this, I would just want you now to sit down for a moment, and I'm hoping very much that you can picture in your mind right now exactly the type of signaling. So when you look at this entire process, I'd like you to just sit and think for a moment exactly what kind of signaling do the mobile nodes actually undergo, and how do the signaling between the mobile node and these other components, foreign agent, home agent, gateway, and so on and so forth, what kind of process actually goes through. Now this is of paramount importance because when we migrate to IoT, we will actually have this big issue that the device that is responsible for sending signaling and receiving signals will actually reduce their energy to a substantial amount by actually sending the signals. Now, as you know, hockey happens to be one of my, it is my favorite game. And when you look at hockey, in modern hockey, when we moved from grass to the AstroTurf, it involves the ball's velocity moves very fast. So when I used to play on grass, we had a lot of the Indian dribble. We used to take one player will beat around 2 to 3 players. As I moved towards playing on AstroTurf, one of the main fundamental changes that I underwent was a new phenomenon of hockey. Meaning that when I get the ball, I count 1, 2, I give the ball, I pass the ball, I pass the ball, I pass the ball. So I transfer that transaction of doing the job because by passing. Now the idea of letting the ball do the work and you don't run with the ball. So I still remember my coach telling me, don't run with the ball. Don't run with the ball because it's one time you run about 20 meters, it takes a lot of energy. So as you run and get, so what you do is we reduce the amount of running and we let the ball do the work. So we do the passing, we do overheads of the ball and so on and so forth. So the idea is when the mobile device, which has very small amount of energy that you have, what is our main thing is we want to control the amount of communication so that we reduce the amount of signaling and we can save a whole lot of energy by doing so. So the idea is now, how do you get something transferred to? Now, if you look at this, common joke I like to share, whenever I get annoyed with stuff, what I do is I keep quiet. Now it's difficult because for people who work with me, because they'll have to read my face and actually understand that something is annoying me, and then they'll have to come and ask me indirectly, and then sometimes when they come and ask me whether something went wrong or is my, so before I can get the message through to people who cannot take direct comments, I have to keep quiet, I have to put a face, I have to sometimes show I'm happy, sometimes I have to show I'm sad, and so on and so forth. It takes double the time for me to get the message through. Now if I had someone who I could just tell straight on the face, this is not a good pen, get it changed, and the person doesn't keep anything in the heart, the amount of energy it takes by the time I transfer the message is very simple. Okay, but so similar in that manner, whenever we look at mobile IP, that's the issue now. Because when you expect the device that is already designed to be small and charming and cute, you will actually have the issue of it actually wanting to reduce the amount of signaling. So basically when you look at this, as I told you, ponder for a while and see what are the signalings that are involved in this. So you have mobility agent advertisements to discover the mobility. So the process that we so simplistic explain involves these detailed processes which you have agent advertisement, registration, tunneling and so on. So you have phase 1 agent discovery, registration, data transfer and so on and so forth. So you can have a look at this. This is a very clear description of data of the movement. So you have the mobile node, you have the foreign agent, you have the home agent and you have the corresponding node. So you have agent solicitation, you have agent advertisement, registration request. After it's registered, you have the registration reply from the home agent, and then you have the registration reply from the foreign agent, and then you have the user packet. So every one of this signal actually consumes a certain amount of energy. Now, and these are more detailed. So as I mentioned to you earlier that we would like to actually discuss about the triangle routing, which facilitates together with the tunneling. So if you look at this, this is the corresponding node, traffic sent through the foreign agent and sent back to the corresponding node, and this beautifully forms the triangle routing. Now, when you look at this triangle routing, it facilitates this. So that means that you don't have the node that is unreachable, you don't have a lost node, and so on and so forth. Now, as we move towards devices, I'm coming towards the end of my presentation, and what I'd like to actually tell you is in the next few slides, this is a work that me and my research team are working on very seriously. And what we are working on is basically we're working on actually doing this mobility management for IoT itself, because as I mentioned to you, in IoT devices, mobile nodes, the fact that my mobile node and I have a power bank with me already, and when I went to buy my power bank, one thing is I need the amount of power, second thing is how long it takes to charge, to recharge it, third thing is about its design and so on and so forth. The fact that this comes along with my phone helps me a lot, because the amount of computation I'm doing, I have fixed energy with it. Now when you move towards the IoT, a very big portion of the devices are actually basically devices which have constrained energy, constrained computation power, constrained memory. Now when we look at this, so therefore we have proposed and developed mobile IPv6 solutions which cater a migration which is a combination of the IPv4 and IPv6. But the major issues, as I mentioned to you, the creation of home agent and foreign agent is philosophical. It's magnanimous, and it has created a solution which is impactful, and it can actually utilize all of these issues to a large extent. Now when we migrate to mobile IPv6, you will have distinct differences, because the fundamental issues of the foreign agent and so on and so forth do not exist in the mobile IPv6. Now, so the main thing is, what happens is when you remove this foreign agent, who does the job? So becomes a big question now. So what we have proposed, I'm just going to go through very quickly. In proxy mobile IPv6, two fundamental issues are important. Number one is we want to migrate the job done by the host. Now recollect again, host is constrained device. We want to optimize its ability to function, and we want it to also facilitate in a manner which is optimized of all its computing resources, energy and so on and so forth. So one of the big findings that you have within the proxy mobile IPv6 is the transcending from host-based solution where the host has to do a lot of work, moving to network-based. Now that happens, it's good because the host is no longer responsible for it, but you pass the job or you create components that are network based, therefore reducing the complexity of the host based. So when you look at this solution, this is a very nice diagram which actually clearly indicates that in host base, the root update is done by the mobile node. Now when we move the solution towards network based, we have other components doing the root update. Now if you can look at this, this is the root update, right, done by the mobile node, and this is the root update done by the network component itself. Now beneficial from this, this is a diagram of proxy mobile IPv6, and we can clearly see that from this there are two new components, which is the LMA, which is the localized mobility agent, and we have the MAC, which is the mobile access gateway. Now what happens is the LMA forms the home network with the LMA address, and then you have the other subcomponent, which is the mobile access gateway. Now the fundamental impact of the LMA and the MAC reduces tremendously the job of the host. So basically the component updates are being done by the LMA and the MAC. Now as you can see, as the mobile node moves and attaches itself to an access router, after authentication the MAC identifies the MN, the MAC obtains the MN's profile, so reducing the node on the work on the mobile node. The MAC sends the proxy binding update to the LMA on behalf of the, this is important. So the MAC sends a proxy binding update to the LMA on behalf of the MN, so reducing the mobile node. The MAC receives the proxy binding acknowledgement from the LMA, and then the MAC sends the router advertisement containing the mobile network home network prefix. So the MAC does the work, the LMA also does the work. So this is our diagram of all the signaling which are involved in the entire process. Now along with this, as I told you, there's a spectrum of solutions which are constantly coming up, because depending on the devices, depending on the network and so on. So me and my research student, PhD student, who is now graduated successfully, Dr. Adnan Jabir, who is from the Baghdad University of Iraq, when he did his PhD together with me, we came up with a new solution which is called clustered proxy mobility management. So as I told you, the idea is to optimize the amount of signaling that we have used, and therefore we will get better solutions. Okay. Now we've published a paper, so I wish I could have a long more time with you. But what we have done is, you can refer this work at the IEEE Systems Journal, which is published in 2016, and we have done a comprehensive survey on the current trends and extensions of mobile IPv6 and proxy mobile IPv6, and in that paper you can see all of the types of a large extent of solutions which have been given to the IPv6 solutions. Now looking at this, what we have done, I will quickly show you, is that we have actually improved the solutions based on the performance metrics. The LMA load, the handoff signaling cost, the buffer packets delay, packet delivery cost, and total cost. Now what we've done is, basically we have actually created clusters of the MAC, therefore to reduce the overload of each MAC having to communicate with the LMA. So the results that we have got have clearly indicated that the method that we have proposed actually has clearly significantly reduced